We've been there from the beginning, when horse-drawn carriages were more than just a tourist attraction, when thunders from the combustion engine ignited the hearts of a generation, when the sky became our new highway, when the moon and stars were not only within reach, but under our feet. Mobility connects cities. Mobility moves mountains, takes us on adventures, breaks barriers and records. Mobility brings us together and brings us home safely. Movement defines life, and for over a century, SAE International has been there, pushing boundaries, driving the evolution of engineering technologies, and keeping watch as the fearless authority for innovation in automotive, aerospace, and commercial mobility. A global community of over 200,000 engineers, technical experts, and volunteers have built SAE's powerful and growing cohort of shared knowledge, creating the most reliable and comprehensive collection of engineering resources and consensus-based standards on Earth. Mobility is the shared gift and aspiration of all humankind. It is our mission to advance that gift well beyond the limits of possibility, while ensuring the safest, cleanest, and most accessible solutions reach the global marketplace, so you can reach those you care about most.
Welcome. I'm Becky Miller. I'm the Vice Chair for SAE Washington DC Section. On behalf of the SAE Detroit Section and Washington DC Section, we'd like to thank you for joining us today. I want to address a few quick housekeeping items before we begin. A recording of this discussion will be shared via our YouTube site at a later date. Aside from the panelists, all other attendees have been muted. That's only to keep your work from home dog and delivery carriers from joining us in this conversation. So we truly want you to participate, and we've turned on the chat function. So please join us in the conversation after the video for the Q&A section. So first, we are going to begin with a quick tour of our IHS test track provided by David Ayler. And then he will be joined by Jessica Jermakian for a Q&A session. If you do have questions during the video, start putting them in the chat so that you can get those in before you forget. And let's get started.
Welcome to the Insurance Institute for Highway Safety's Vehicle Research Center in Ruckersville, Virginia. My name is David Ayler, and I'm the Manager of Active Safety Testing here at our Research Center. For the next few minutes, I'm going to take you on a tour of our outdoor and covered test tracks and discuss our crash avoidance programs. Let's go. Our upper test track is roughly 1,200 feet long by 300 feet at our widest point. We also have a trackside support building with offices as well as vehicle bays to equip the test vehicles. One of the unique features of our test track is a local positioning system. We have 16 satellites mounted around the test track so that we can accurately position vehicles and targets and not necessarily rely on GPS or satellites in space. One of the tests we conduct on this outdoor test track is our headlight test. Let's talk about that now. Headlights are the original crash avoidance feature. We know that roughly 50% of fatalities occur at night, and headlights could have a huge impact on reducing that number. We've done several studies looking at the effectiveness of headlights, and we've seen better headlights lower insurance claims, and we've also seen that better headlights help drivers see further down the road. So we developed a test that we conduct here on our outdoor test track. We get vehicles off dealer lots just like consumers. We equip it with our positioning system, and we run the vehicles through several different scenarios. We go through a straightaway section, We drive the vehicle through a curve at a 150-meter radius, and we also drive the vehicle through a curve at a 250-meter radius. And in all of those, we look at both the low and high beams. We also evaluate and give credit for vehicles with high beam assist, which automatically switches between low and high beams. In order to evaluate these vehicles, we use these sensors that were developed specifically for this test. We look at the visibility at the edge of the road, and we also look at the glare at the height of an oncoming driver. It's important that we maximize the visibility, but reduce the glare for oncoming drivers. Since we started in 2015, we've seen a drastic increase in the vehicles that earn our top rating of good. In 2015, only 3 models got a good rating. Today, about 30% of the vehicles we test earn good ratings. Now, we know the importance of headlights, but there are other crash avoidance features that help reduce, mitigate, or avoid crashes with pedestrians and other vehicles. Now let's talk about autonomous emergency braking. These systems work by using forward-looking sensors like radar or camera to detect obstacles in front of the vehicle. We know they're highly effective, and we've also seen that over the last 10 years, there's been an increase in pedestrian fatalities. And so these systems, not only can they recognize other vehicles, which we'll talk about later, but they can recognize pedestrians. And they first warn the driver through an audible or visual warning, and if the driver doesn't respond, they'll automatically apply the brakes to either mitigate or avoid a crash. So right now, we're set up for one of our pedestrian scenarios. This is a child scenario. The child starts behind 2 parked cars, runs out in front of the vehicle to about the 50% overlap point, and we run those at 20 and 40 kilometers per hour. The next scenario that we run involves an adult starting at the side of the road and walking out in front of the vehicle with a smaller overlap at 25%. Again, those tests are run at 20 and 40 kilometers per hour. The third scenario we run is with a stationary adult in the middle of the road at a 25% overlap with the vehicle. These are run at 40 and 60 kilometers per hour. So let's get this vehicle set up and we'll run the test and see how it does.
We are ready when you are.
Okay, on my way.
Now we're running at 40 kilometers per hour. Let's see how the vehicle does. And you can see it avoided the crash with our pedestrian dummy. We've seen drastic improvement in pedestrian front crash prevention systems over the last 2 years. In 2019, when we first started evaluating vehicles, over half either had no pedestrian AEB or didn't earn credit in our test. For the 2021 model year, almost 75% earn one of our top ratings of either advanced or superior. Now let's go to our covered track, which you see behind me, and talk about some other crash avoidance technology. We're now at our covered test track. It's one of the largest fabric covered structures in the world. It's 700 feet long by 300 feet wide. We can fit several football fields side by side. We actually designed it with radar in mind. You'll notice the fabric is inside of the metal structure. We also can test no matter what the weather conditions. There are 18 concrete piers around the outside supporting the structure. We used over 7,000 tons of concrete, and the largest concrete pier alone used 30 truckloads of concrete. You'll notice the parts of the piers that you can see, that's about 70%, but underneath there's another 30% of concrete, and within these piers, there's over 39 miles of reinforced rebar. Earlier today, you saw a front crash prevention test with a pedestrian, but we know these systems are also highly effective against other vehicles. Our data has shown that front to rear crashes are reduced by 50% with these systems. And so this is the target we use. And you'll notice visually it looks like the back of a car, but it also needs to look like a back of a car to radar. And so underneath this, there's radar absorbing material and there's radar reflecting material. So it looks like a vehicle to radar. So we're getting ready to run our test, and we're going to get out of the way and see how the vehicle performs.
Rock and roll, Robbie.
10-4.
So you just saw that vehicle avoid a crash with our target at 40 kilometers per hour. That's pretty common now for these vehicles, and in fact, 20 of the manufacturers have made a voluntary commitment to make autonomous emergency braking standard on all but their heavy vehicles by September of 2022. We also have more advanced targets like the one you see here. This is our 3D target. It looks like a vehicle for cameras and radars all the way around, and it's actually impactable and breaks apart. We've used it for some of our research testing for offset scenarios, for angled scenarios, and in fact, we've also used it to show the effectiveness of autonomous emergency braking on heavy trucks. Our data has shown that there's a 44% reduction in those types of crashes. A neat thing about this, we've also used it for our rear autonomous emergency braking test. Rear autonomous emergency braking is a system that uses ultrasonic sensors that beep at you and then will automatically apply the brakes if there's an imminent collision when you're backing up. And our data has shown that those type of systems can reduce those types of collisions by 80%. So we've used that target for that testing as well. We can also place this 3D target on top of our robotic platform. And that allows us to do more complicated procedures where the vehicle can start and stop. It can come from the side. We can even perform cut-in maneuvers with another vehicle to see how the AEB performs in more complex scenarios. In order to do that, we also have to have equipment in the test vehicle. This vehicle is equipped with a steering robot. It also has an accelerator and brake robot so that we can perform more precise, accurate test procedures with our 3D target. Thanks for joining us today for the tour of our test tracks and the discussion of the different crash avoidance features that we test, from headlights to front crash prevention. We also talked a little bit about some of the research testing that we're doing with our more advanced technology. We're going to be looking at driver monitoring systems as well as pedestrian AEB at night. So with that, I'm going to close it out here and I'm going to open it up to any questions.
All right. Thanks for the video, David. So we've already have some questions coming in. Please, if you have questions about what you saw in the video about our test track operations, really anything about IIHS more broadly, please make sure you put it in the chat. If you put it for everyone to see, I will be monitoring the chat and asking, talking with David and asking questions. So we've already had a couple questions come in. So do you test and evaluate the night vision heads-up display, and how do you evaluate that?
Yeah, right now we don't. Again, our night testing right now is just focused on headlights and how well they illuminate the road and prevent glare. But that does lead me to one of our research projects. We're looking at how pedestrian systems perform at night. We know that a lot of the fatalities, about 75% of pedestrian fatalities, occur at night. And so we're starting to look at those systems, you know, and infrared type systems are available. There aren't any currently that are tied to the braking, but that's one solution that manufacturers might employ to address nighttime pedestrian crashes.
That sort of brings me to a question. You talked about in the video a lot of different types of sensors and you just mentioned a couple more. You talked about ultrasonic, radar, cameras. Why are there so many different types of sensors?
Yeah, great question. I mean, I think different sensors really have different pros and cons. And so I would say, most systems now have a fusion system that has a radar and a camera. And, the camera is really good at sort of detecting what the object is, whether it's a pedestrian or a car. Radar is really good at, more accurate distancing. It also works in different weather conditions. But we also do have systems out there that are camera only or radar only. And, there's other technology that's being talked about a lot, like, LiDAR or infrared. And so we're starting to see some more sensors. I also think as we get more automated or partially automated vehicles, we're going to need more redundancy with these sensors. And so they're constantly checking and balancing each other, to make sure that what they see in front of them is in fact a threat or a target.
Great. Questions are just coming right in. So with reference to, some prominent automakers cheating scandals, do you have different test scenarios for pedestrian prevention so that the system is not tuned for your specific test conditions, but rather for daily cases?
Yeah, that's a great question. I mean, it's always a balance of making the scenarios realistic, and it's sort of not predictable. But at the same point in time, because we're rating these vehicles, we need to make sure that it's repeatable and reproducible. We want to make sure that, manufacturer A and manufacturer B are being evaluated in the exact same way. And so all these tests are developed by first looking at the real world problem and saying, what kind of scenarios? Is it an adult or a child? Is it crossing the road or standing in the road? And that's how we develop the scenarios. And we'll run those tests, for a number of years. And then we always go back and we look and see how effective those type of systems are in the real world, and also decide, do we need to make some changes? Did we miss something, or has the pattern of crashes changed? And so we're constantly updating that to address that. Talking about sort of cheating, one of the ways we sort of avoid that is we do get cars off dealer lots for all of our testing, just like you or I would buy a car. And so, we purchase them from dealerships, all around the Virginia area.
Great answer. Lots of questions coming in. Have you developed a test plan to evaluate adaptive driving beams or glare-free high beams?
That's a great question. And so, these are headlights that sort of have matrix of LEDs that can turn off, different arrays to sort of prevent glare. We've looked at different scenarios to how to evaluate that. But right now, until the federal government in the US really comes out with a standard, so those headlights are really not allowed in the US. And so until the federal government allows them, we really can't figure out how to evaluate them until we know what they look like. And so it is on our radar, but we're just sort of watching the federal government right now.
And somebody asked a question that's related. Do you see any movement with the federal government in matching what's going on in Europe in that area?
I haven't seen anything recently. They did publish some protocols, draft protocols. They were pretty detailed. A lot of manufacturers had some back and forth. And so it'll be interesting to see where they go. We do know, in our headlight test, we give credit for high beam assist. We do know drivers don't use their high beams. And so the idea of basically having high beams all the time, except where other cars are, pedestrians or street signs, has a lot of potential. So we would like to see that technology be available in the US market.
And thinking about the performance of headlights, and you mentioned in the video that they're the original crash avoidance system, which it's interesting to think about it that way. But you also mentioned that automakers have really responded and improved the headlights dramatically since the first ratings, but you still said only 30% get a good rating. Can you talk a little bit about why that is, what the issue is?
Yeah, so it's an extremely challenging test, and I think very quickly manufacturers sort of figured out what they, sort of the issues they were having. And one of the big problems was aim. just, if you have a good light, making sure it's pointed in the right direction. And again, not too low to limit visibility, but also not too high to glare oncoming drivers. And it's a challenge because that starts at the supplier, making sure the headlight tolerance is low, and then installing it on the car, and then making sure it's aimed. So there's a lot of buildup of tolerance, and I think manufacturers quickly tighten that tolerance. But even the challenge of the height of the headlight. So in the U.S. market, about half of the vehicles are SUVs, and so if you have a higher mounted headlight, it makes it challenging to get enough visibility down the road without glaring oncoming drivers. We've started to see some products, SUVs that have their headlights mounted lower, which I think helps that. And so, we are seeing some progress. I will also mention that, headlights are an interesting safety feature because on many vehicles, there are 2 to 3 options. There's a base headlight, and then, there are other more advanced features. And so we evaluate about 400 or so headlights a year. And often on the same model, you can have a range of results.
Yeah, that's a really good point. Moving on to other types of technology, there's a comment starting with greetings from Mexico. So somebody joining from Mexico. Do you think in the future it will be mandatory for all cars, even the cheapest ones, to have anti-collision systems?
Yeah, great question. I mean, whether it will be mandatory, that's a good question. But that's where the voluntary agreement comes in. I mean, I think the manufacturers, as well as IHS and its Consumer Reports, who got together and came to that agreement, we felt like a voluntary path was much faster. Anytime anything goes through regulations, there's several years for it to be written up, and then there's sort of a phase in. And so we thought that was the fastest approach. And basically, that's September of 2022 when it will be standard on most vehicles. And we're really already seeing that, again, from the cheapest models you can buy all the way up to the most expensive. And in many cases, we talked about technology. The cheaper cars will have maybe a camera only, which does fairly well. And maybe the more expensive ones will have a camera and a radar, and that radar will add adaptive cruise control or some other features, for the consumer.
Sure. So you talked a little bit about the sensors and what the different sensors are good for, and you just mentioned it again about different types. Have you noticed any trends in performance of safety systems based on the sensor type? Does one seem to be superior?
Yeah, that's a good question. I don't know if one is superior. Like I said, it seems like most manufacturers are heading to a fusion system of a camera and a radar. And I think that combines sort of the best of both worlds. We do still see some systems that are camera only. And the downside of that is that maybe not in our tests, but in different weather conditions, the camera may not work. And radar has advantages, but we have seen in some of our tests that the radar struggles with a stationary pedestrian, for instance, not seeing that movement. And so I think they both have their benefits. And so, again, one of the reasons why I think we're seeing manufacturers sort of combining and going with a fusion system.
Are you testing things like level 4 automated vehicles?
That's a great question. I mean, we are starting to look at sort of what we call partially automated systems. There's a lot of organizations, Euro NCAP, looking at the functionality of that, and we are looking at the functionality, how well they stay within the lanes, and how they maneuver hills and curves, and what happens when vehicles cut in. But we are also focusing on how the driver stays engaged. So all of these systems really right now, they're sort of level 2, and the driver is responsible for the task of driving, hands on the wheel, aware of what's happening. And we know there are a lot of high profile crashes where there's a lot of debate on that. And so right now, one of the things we want to focus on is making sure that the driver really is still in the task of driving. And so one of our research projects is looking at driver monitoring or driver management, and whether that's a camera looking at the driver or monitoring hands on the steering wheel. No matter what level the system, keeping the driver engaged, I think, is a huge safety an issue, and we want to make sure the driver's engaged.
Yeah, for sure. I'm going to give you a break from talking for a minute and answer this question. Someone asked the question, last year with COVID, miles traveled was reduced by about 16%, but the number of crashes with fatalities increased by 7%. Any comment on why this was counterintuitive? So great question, and one everybody in this space is certainly trying to understand the effects of COVID on traffic crashes and exactly why the what happened during the traffic issues with COVID. But one of the big issues that we saw was that speeding was up, and speeding is of course detrimental when it comes to fatalities. Speed kills, of course, and so that's one of the things that we've seen. As traffic was down, speeding was up, and the ultimate result is more fatalities during that time period. But we have lots of research, we and others have lots of research going on now that the data are coming in from this COVID time period to really understand what happened. Let's move back to crash avoidance. Living in Michigan, I was wondering, do you test these safety braking features with hazardous road conditions such as ice? And then someone else added on to that question, and also potholes.
Yeah, those are great questions. That's not part of our rating, but I will mention one of the things we're always looking at real world and how well these systems work. And we have done a study recently looking at police reported crashes and sort of what scenarios are missing from AEB. And some of those are sort of more complex, whether the vehicle itself is turning or it's following a vehicle that's turning. But one of them is we recognize AEB isn't as effective in different weather scenarios. And as most of you know that are hopefully good drivers, when there's snow or ice or rain, you're really supposed to give more distance, right? Not brake as hard. Right now, these AEB systems, they don't take that into account. It's possible in the future they could, say, oh, the wipers are on, it's raining, or they know that traction control is slipping, so I should brake earlier. And so we did some tests a few years ago. It was snowing. We decided to go out on our track and sort of have some fun. And we ran the exact same tests with a basically snow covered surface. And what we found was that the vehicles basically warned the driver at the same time, and they started braking at the same time as in good weather conditions. But again, because the friction was lower on the surface, the deceleration wasn't as great. And so we saw more impacts. And so again, we aren't testing that. It's very challenging to have a repeatable test with whether it's snow or water, but we do recognize that's a challenging situation. In terms of potholes, we don't. Thankfully, our track is nice and smooth, and but we do recognize that that's a challenge. And I'll just throw that out there. That and other road conditions like how well lane lines are painted is going to be a consideration as we start talking about more automated vehicles. So not only do the vehicles need to be able to manage that, but we need to have good infrastructure to support the automated vehicles.
So one of our questions is about whether we've considered wildlife.
Yeah, we definitely have. Our insurance sponsors, they pay a lot of money for deer impacts. I know that's a big deal in Virginia. It's a big deal in Michigan for a lot of you folks. And so we are starting to look at that. I mean, I think with any of these technologies, it sort of starts with basic, right? Front to rear, very clear vehicle. They're expanding to pedestrians, to bicyclists, to even large animals. And it's getting more challenging. And one of the challenges with animals is their behavior is unpredictable. And these systems have algorithms to sort of determine if they think an animal or a pedestrian or a car is going to, be in their path and when they need to start braking. And so as we probably have all seen, deer can jump and turn, and, I've been hit in the side of the vehicle by a deer before. So that's going to be challenging, but we are looking at that, and even a thermal camera maybe can at least highlight, that there are deer around where a driver may not be able to see that.
Everybody keep the questions coming. We're about halfway through our time, but we have plenty of time to answer questions. There are, we definitely have more. So let me jump into the next one. Is the Institute, and you've already talked a little bit about this, considering expanding the test tracks in the future or expand active safety testing capability?
Yeah, so expanding the test track is probably challenging. You know, for any of you that've been in Central Virginia, it's pretty hilly, but that's always a consideration. But I will say that one of the big things now is as we test more automated systems, you know, these are going to require some testing, I think, on actual roads. Many of the systems are sort of geo-fenced or mapped on actual roads. Our test track isn't mapped. And so that may mean we need to evaluate some of these systems, you know, in more real world environments, you know, and in situations where, you know, a test track is just too restrictive. And so I think that's going to be a big challenge for a lot of test houses moving forward.
Yeah, for sure. Do you see that IIHS will evaluate other technologies like blind spot monitoring?
Yeah, we're looking at all those technologies and the effectiveness. Blind spot's an interesting one. That's a feature that consumers really seem to like. It does seem to reduce crashes. But I think NHTSA has done some studies and some other folks that have shown there's not a whole lot of difference between how those systems perform. And so we really would like to, you know, highlight areas and encourage manufacturers to maybe install safety equipment that otherwise is not being installed. And so, you know, we are looking at, you know, different technology to promote.
Great. Who pays for the tests?
Yeah, so we're completely supported by the insurance companies. So all the big names, the State Farms, Allstate, Geico's, support us. We are a nonprofit. So that's where our funding comes from. A lot of our tests are nominated by the manufacturers. So manufacturers, you know, want to get the top safety pick award for their vehicles. In those situations, if it's not a planned test for that year, you know, we basically tell the manufacturers, yeah, we will run the tests, but we ask that you reimburse us for the cost of the car. So we still buy it off a lot like anybody else. We don't charge for the test fee in that situation. We just charge them for the car. And so a lot of our testing is nominations because the manufacturers want to be able to show that their vehicle is safe and that they've designed it for our testing.
Your pedestrian dummies look like they're walking. That seems really complicated. Is that necessary?
So that's a great question, and you can probably ask a lot of people whether it's necessary or not. Depending on the technology that's being used and how the manufacturers are interpreting that, it, you know, may not be necessary, but it is the most realistic scenario, right? That a pedestrian is walking across the road. Some systems, you know, do look for head and shoulders. They do look for legs moving, you know, to verify that it is a pedestrian. And so, you know, we think that's probably the most realistic scenario, to have it, you know, a walking adult instead of sort of look like somebody's skateboarding across the road. It's not terribly complicated. There's a motor sort of located in the hips of the dummy, and as soon as the system starts sort of pulling the pedestrian across, that motor starts moving the legs. And so visually, I think makes the most sense.
And this kind of goes back to an early question about, you know, whether automakers are designing to the test. And we know, at least in the early days of the pedestrian detection systems, the automakers were training the systems. There wasn't testing necessarily available, or so they were training the systems on real pedestrians, on real roadways, not obviously just making sure the detection systems and the algorithms were working correctly. And so they were focused on real pedestrians. And then when you move to a test setup, you need to have a surrogate or something that looks like the actual target that you're trying to prevent the impact with.
Yeah, that's a great point. One of our early pedestrian dummies, you know, it walked, it looked good, but it was suspended from a cable. And some of the manufacturers told us that, you know, their system was a little confused because they were picking up a 20-foot high obstacle, which they knew was not a pedestrian. And so that's why most of the systems ended up going to the sort of platform driven system instead of a overhead carrying gantry system.
Yeah. As more cars reach the top safety rating, do you see a revamp in the criteria for the top rating or including other safety feature evaluations?
Yeah, absolutely. We're always sort of pushing the bar higher. And so we know in a couple of years, we're revamping some of our crash worthiness tests to make them more challenging, to make them sort of match some of the issues we see in the real world. And we're doing the same thing with active safety. So we know that adding a nighttime pedestrian will really address a lot of fatalities, looking at more complicated AEB scenarios. And so we are always trying to sort of push the bar a little bit further, and manufacturers always want to achieve that top safety pick.
Yeah, and on that front, do you anticipate testing other modes of pedestrian engagement or vulnerable road user engagement, like bicycle riders or riders on e-scooters?
Yeah, it's something, we are seeing more people, on e-scooters and bicyclists. And just like I talked about earlier, scenarios getting more challenging and systems recognizing things. We have talked about, the bicyclist scenarios in the real world and trying to address those. And so that is something that we're considering.
You've talked about this a little bit already. We've talked about the sensors, but there's a question about, as radar, LiDAR become more prevalent in vehicles, is there some consideration for sensors when testing for other tests? For example, radar can pick up objects better than the human eye during the headlamp test. So. Yeah, so,
it's definitely a good point. And, radar is should perform the same in the day, during the night. We know the camera, it really relies on visibility. But one of the things, we try to design our tests so that it's sort of sensor agnostic, right? We want the test to be based on the real world data. So if we know a lot of pedestrians are dying at night, we really want to address that. And then it's sort of up to the manufacturers on how they handle that, right? Do they make sure there's a radar? Does the radar have sort of more weight at night, And so same thing with headlights. Our headlight test really is not about the lighting technology. It's about illuminating the road, and whether that can be done with a halogen or a HID or an LED doesn't matter to us. We just want the end result to be, better performance, avoidance, visibility, whatever the case may be.
So this is a tough question coming from our own. What are your thoughts about integrating AEB into crash testing? For example, allowing a vehicle with AEB to brake prior to impact during a frontal crash test. And I'll expand that to include just thinking about how do active safety and passive safety, come together, and whether we'll consider testing that in the future.
Yeah, I think we'll definitely consider it if we think it's applicable. One good example would be, we know that some systems sort of in front to rear, might move the seat or close windows, sunroof, tighten the seatbelt, sort of address those things. Right now, many of these systems aren't they're not effective in sort of front to front crashes. So our moderate overlap or small overlap, they're probably not going to break in those scenarios, so they're not included. Or our side impact, for instance, many of these systems right now aren't necessarily designed for a wider field of view, with a vehicle coming from the side. And so I don't think that's an issue now, but that is a great point as we move forward, in determining, how we handle that and what that looks like.
And thinking about that in kind of a different crash mode is, we're doing research right now, thinking about how we might upgrade our whiplash test in the future, and how we might improve it and increase the robustness across the range of real world situations that result in front to rear crashes. And one of those is potentially, you know, an AEB event that is followed by a rear impact crash where that driver might be out of position a little bit because of the aggressive braking from AEB. And so we are actively doing research to understand how we might incorporate that kind of situation into our testing programs. So let's move on to another question about AEB. Some automakers label their AEB systems for low speed use. Have any evaluations been done for AEB systems at speeds greater than 40 kilometers per hour? And are we considering a higher speed test?
Yeah, so we've done some research looking at higher speeds, 50 kilometers, 60 kilometers. And that's one of the things we've talked about in you know, advancing our testing is what happens at higher speeds. And I think some of those low speed systems were early systems with LiDAR, early LiDAR that sort of had limited range. And that's why they only worked at low speeds. And so we are considering that. I will mention again, you know, real world data shows that these systems are highly effective. And I think one of the reasons for that is, you know, most of the crashes, front to rear crashes in the real world, you know, often are at lower speeds, bumper to bumper traffic, you know, but we do know there is room for improvement. And again, some of the real world data has shown that, you know, on roads with higher posted speed limits, the AEB may not be as effective. And again, that's because, you know, higher speeds, it makes it more challenging because the vehicle needs to recognize it earlier. It needs to apply the brakes earlier. But definitely something that we are considering as we, you know, make our front crash prevention more challenging.
And you mentioned those statistics in the video, and you've mentioned them here. The reductions in real world crashes based on these crash avoidance technologies. Where do you get those numbers from? How do you know that?
Yeah, so in most cases, we have to work with the manufacturers, and early on, many of these features were optional. And so we would work with the manufacturers, and they would basically give us a list of vehicles that had the feature and a list of vehicles without it. And so as best we could, we would compare apples to apples, the effectiveness of the vehicle. So, you know, a Honda Accord with the feature compared to a Honda Accord without it. And we could really get an idea of, you know, truly how beneficial the system was. And so we've really worked with our sister organization, the Highway Loss Data Institute, to collect a lot of that data, looking at insurance claims as well as police reported crashes to get those reductions.
Great. What are your thoughts on greater consumer acceptance? Based upon your experiences, what are the challenges with getting these technologies more acceptable to consumers?
Yeah, that's a really good question. And we've seen various levels of acceptance. I mean, we know blind spot consumers seem to like, and I think that's because it's less annoying, right? You don't see the light or the blinking until you really need it. AEB is really a last minute feature, but we have seen that a lot of early lane departure warning systems, consumers just really didn't like them. We did some dealer surveys looking at the acceptance, and in a lot of cases, consumers would turn it off. You know, they felt like it was a backseat driver, you know, beeping at them when they, you know, got closer to the lane or crossed the lane. And so there really is a balance between, you know, the consumer being comfortable with the technology, not annoyed, and leaving it on. Same thing with forward collision warning. If the system's constantly warning you in scenarios where it, you know, doesn't need to be, people will turn it off. And I think systems have gotten better. Some early systems, you know, railroad crossings would set them off, or metal bridges. Yeah. The federal government even runs a test, you know, with a 1-inch steel plate in the road to see if it goes off. And so I think manufacturers are getting better at sort of not having those false activations, but it's always a balancing act.
Yeah, for sure. The systems have gotten much better about that. But another question is related to that is, do we test AEB systems for false positives? Do we evaluate that in some way?
We don't. We sort of have left that up to the manufacturer. We want to make sure that the system performs and is safe, you know, it's avoiding. But we kind of leave that on the manufacturers, that they're not, you know, annoying their customers. we've talked about some scenarios. For instance, what happens if that pedestrian that walks out from behind the car stops right before he gets to the lane? What does the car do? But for now, again, we've sort of left that responsibility to the manufacturer.
Yeah, and we have not in our track test, but in our research, we have looked at systems and looked at how likely or how often consumers leave them on. We've looked at vehicles that have come into dealers for service, and we've looked at front crash prevention systems and also lane departure warning systems. And as David mentioned, we did see that there was a big difference in lane departure warning systems. With some of the more annoying systems, people were more likely to turn them off. The less obtrusive ones people were more likely to keep them on. And we've even done, followed that up with track tests to see what are those differences in those systems, and can we identify what makes a system more annoying or less annoying. But generally speaking, when it came to front crash prevention systems, those were much more likely to be left on. So I think the false positive issue is much less annoying in that range of vehicle or that technology than in lane departure warning, where we saw huge differences in keeping the technology on. So we have a question here about some test operations. How long does it actually take for you to rebuild the GST?
That's a great question. It's something we're still getting experience with, and I think it depends on the scenario. How many parts fly off and where they go, and sometimes the parts you need are in different areas of the track. And so I think putting the GST back together is probably a 15-20 minute job. I think it just all depends on how far the pieces are flying. Can even depend on how windy a day it is. But it's definitely a challenge. One of the things we've talked about doing to keep test flow up is having two of them. So, you have one in test, it gets hit, you sort of brush the pieces off to the side, have one team setting it up. There's another one already completely built that you put on the target so that you can run the next test. And while that test is happening, you're rebuilding the backup, and you just sort of continue to repeat that process.
Yeah, so it sounds like from the video, you talked about a lot of different tests that we do on these vehicles. How many individual trials do you do for each vehicle, and how long does it take?
Yeah, so for most of our tests in each scenario, we do 5 repeat runs. So for instance, you saw a child scenario with the vehicle at 40. So we would do 5 what we call valid runs, making sure the speed is within our specifications, the lateral position. And so we do that 5 times. We do it, 5 times at 20 kilometers. We do, the crossing adult 20 at 5, and so on and so forth. And so, for instance, the pedestrian test can take 3 to 4 hours, depending on how good the driver is that day. The AEV test, the tolerance is not as tight, so we can usually do that test in less time. Some vehicles are harder to maintain their speed, and right now all our scenarios use a test driver, and that's just easier set up. But as tests gets more complicated, and we use the driving robots, the test setup time and time in between the tests will increase.
For sure. What do you think of the promise of Volvo, the Swedish car brand Volvo, reducing deaths and several severe injuries by limiting the speed to 110 miles per hour? Is that something other brands should do?
Well, first of all, 110 is still really fast, and even the safest cars, if you get into a crash at 110, there's only so much they can do. We always like to say, you can't defeat physics, but I do like the idea of reducing speeds. I mean, we know, the higher speed limits go, the more fatalities that occur. I mean, we've done studies looking at since we've gone away from a national speed limit, how many fatalities have occurred. But along those lines, I mean, I think this is another area talking about combining crash avoidance and crash worthiness. We have cameras on cars now that are picking up speed limit signs, right? And most of them just sort of tell you what the speed limit is. But maybe it would be safer for them to actually limit the vehicle speed, right? If the sign says 55 and the camera sees that the sign says 55 or has GPS that says it's 55, should it allow you to drive the car 65 or 70?
Or 110?
Yeah, 110 is crazy. But that's a question. And, that's another question with automated vehicles or even adaptive cruise control, right? I mean, adaptive cruise control allows you to set the speed at basically whatever you want. And is it okay for a car to set the speed at 70 when the speed limit's 60? I think that's a different discussion, but something to think about.
Yeah, and it kind of goes back to an earlier question that was, there were those questions about consumer acceptance, and kind of a follow-on to that was whether if we sold ADAS and automated features more on safety rather than convenience, would that improve acceptance? And thinking about, having a driver assistance system that limits your speed based on the speed limit, that it really goes to the heart of consumer acceptance and whether that's an acceptable option for, whether consumers would pay extra money for having a vehicle that will limit their ability to drive the way they want to drive on the roadway. All right, looking through some more of the questions. We did get a question about whether the recording would be shared with the attendees. Yes, we said that at the beginning. We are recording this and it will be available on a YouTube channel, SAE Detroit's YouTube channel. Maybe you guys want to put that in the chat if you have a link to that. Do you need special care for ADAS testing for electric vehicles?
No, not like crash worthiness. The only challenge there is just making sure that the vehicle is fully charged before we start testing. That's it's very easy to, as everybody knows, to fill up a car with some gasoline and make sure you have plenty of mileage to test a car. We've gotten a few research or pre-production electric vehicles arrive at our facility for testing a few hours before, and they're basically completely dead. And that means we've got to, plug them up and hang out for a couple hours until they fully charge. So no special cares other than, the same considerations that the public has to think about when they drive them.
Yeah. Have you started testing connected vehicle features?
We have not. We are monitoring, that and making, just sort of keeping up with it. But, again, it's an area where I think it depends on where the government goes. Different manufacturers, I think, have sort of different ideas of what the best, strategy or frequency is. And so, again, I think that's an area we sort of have to just monitor and see where everything settles out. But I do think that there are scenarios where that would be hugely beneficial. A side impact scenario where the vehicle systems, the camera, can't see a crossing vehicle. It's going to need something like V2V to know where the other, targets or vehicles are.
Yeah. And a second part of that question, and I can answer this one, is whether we've looked at telematics data for analysis of safety and risk taking. And a couple of comments on that. For one, we know that some of the insurance companies are doing that to set rates. That is not at IIHS, even though we're fully funded by the insurance companies, we are not in the business we are not in their business of setting rates. So we don't have access to that data and haven't analyzed that data. They are certainly doing that for their own business purposes. But thinking about it kind of more broadly, it's really interesting. We know that in the commercial vehicle space that, many of the commercial vehicles, the heavy truck carriers are using telematics data to monitor, what their drivers are doing and, try to identify risky drivers for interventions and things like that. And that's another area where it's fascinating work, and they're doing it in the purpose of their business, but it's not data that we have access to or we've been able to analyze for our own research purposes. So here is a question about, can you give a quick update on the IIHS research and rating of seatbelt reminders? Yep, of course. So we are introducing a new seatbelt reminder rating system. We hope to introduce it this year. We had some challenges with COVID in collecting the data we needed in order to issue the ratings, to take the readings from the vehicles and put out the ratings. But with vaccinations and improvements in the COVID situation, we have started collecting data on that. And so stay tuned. We hope to put out ratings for seatbelt reminder systems sometime this year. Another question, who can we reach out to if we have questions after this meeting? If you have if you have questions about IIHS and the test track, any of our crash avoidance testing or crash worthiness testing, you can reach out to me or David Ayler. I believe at some point we will have our email addresses up. If you have questions for SAE Detroit and SAE Washington, you can reach out to those groups individually.
And with that, we probably have time to take one more question if someone has a question. Otherwise, we will put up the contact information slide for Jessica and David. And thank you again for taking an hour out of your time to do this question and answer session, to join us here. And thanks to all the folks at SAE Detroit and Washington, DC sections for helping to set up this meeting. So again, if you have questions directly for our experts, their contact information is listed here. If you have questions for our sections, you can find us on our websites or on SAE.org. You can locate our email addresses for our sections. This presentation will be recorded, will be put up on the YouTube channel for SAE Detroit, and will be shared on the SAE Washington DC webpage as well. So if you have colleagues who were unable to get in or unable to attend at this time, this information will be available for you on demand. So thank you again for joining us, and have a great rest of your day. Thanks.